Hi, so I'll quickly take you through my COS 802 project, and it's on deep learning for sentiment analysis for African languages. Just to quickly go into the introduction, in this presentation, we explore deep learning techniques for sentiment analysis on 14 African languages. We focus on computationally efficient models due to resource constraints. We used a pre-trained model, DistilBert, which is a mini version of the BERT model, to classify sentiment on multiple languages, multiple African languages into five different categories as shown on the screen. The research question that we are trying to answer is how can we employ computationally efficient models for multilingual sentiment analysis for African languages? So in this presentation, I cover my methodology and then I discuss my findings and then we go into the conclusion. So just to quickly go through my methodology, I used the Afrisent dataset, which had 110,000 tweets in 14 languages. The dataset meets the three V's of the big data definition. To pre-process my data, I had to basically uh, combine the different CSV files because it had different CSV files for different languages. I had to basically combine those files into one data set, and then I loaded the data into chunks also due to resource constraints. And then I split my data set into 80-20 and trained the data on 20% of the data set. Sorry, 80% of the data set I used to train the model, and then 20% of the data set I used to test the model. I had to clean up my labels to remove basically missing values and standardize the labels. Um, Okay, so the model that I used, like I said, is this DistilBert model. I trained it on 3 epochs and 4 data batches. And to evaluate the model performance, I used the precision, recall, and accuracy metrics. Okay, and then the hypothesis was that the model would basically be biased towards the well-represented classes in the data set. And then the other hypothesis was the model selection. So because we had to go with the DistilBert model due to resource constraints, the model may not be able to cover nuances as well as a larger model would have been able to. So just to go into my findings, you will see that the training loss is decreasing, which basically suggests that the model is learning as we increase the epochs. For the validation loss, you'll see that after the second epoch, there's an increase there, which suggests that there could be overfitting in the model. Um, Okay, and then just to go into my model and the coefficients. So again, like the hypothesis has been proven true because the classes that are less frequent in the data set showed a relatively poor performance with mixed sentiment scoring the lowest, but other classes still have good enough scores for us to continue using this model. Um, Okay, in conclusion, a lot of sentiment analysis work has been done on focusing on high resource languages, but this study basically filled in the gap or contributed to filling in the gap where employing deep learning approaches for sentiment analysis on low resource languages. Um, there is an opportunity to employ a larger model where constraints allow, such as your XLM-Roberta or BERT, which would be able to cover the nuances properly or better than the model that we used in this project. My model accuracy or the DistilBert model accuracy is 69.63%, which we feel is good enough to proceed with using this model. Thank you.